All right, good morning, everyone. Nobody is logged in right now, which is totally fine. I had people trying to get in before, but I had a call from my doctor, and since I didn't want to put that online, basically, it just got into the system right now. So today is day 45. All right, today we're going to go over chapter 14 and chapter 16 of the text. All right, as it says right here, I've decided to make tomorrow a lab period, so I'm not going to do any taping. The reason for that is stated right there. Out of the dozen or so students that are in the class right now, approximately 30% have yet to turn in the chapter 12 test. Now, to be fair to those people who did turn it in on time, if you turn it in today or tomorrow or whenever, you'll have some kind of a points deduction. But that said, you'll still get most of the points if you've done the work correctly. In the same way, several students either haven't turned in the written test or haven't turned in the homework or both. Now, as of right now, because I went online yesterday and I was grading, I believe that other than yesterday's test, I'm up to date. So if you disagree with something, as always, please let me know that I'm missing something or whatever, and that's totally fine. All right, and I will grade it as soon as possible. I'm also going to be grading this weekend. I'm going to be grading tests. In fact, I'll probably start tomorrow morning. All right. Now, the other thing I'm going to say, as it says there, is I have attached the homework for chapters 14 and 16 to the email. I don't think it's going to make a lot of sense to go over this homework with you until we've gone over chapters 14 and 16. All right, that homework will not be due, of course, not this Sunday. That would be ridiculous. It's be due a week from Sunday. Now, I want to kind of give you for lack of better words, sort of a roadmap with what we're going to be doing for the rest of the semester. All right, so let me just do this. So I'm going to put in here, for example, week of, and next week then will be the week of 3/18. All right, so the idea is we'll be going over chapters 14 and 16. We'll be doing that on Monday, on Tuesday, and on Wednesday. As of right now, your next test, which the good news is it'll be your last hands-on test for chapters 14 and 16, will be next Thursday, which I believe is like the 21st if I've got yeah, that's a week from today. So on that date will be the chapter 14 and 16 hands-on test. Again, it'll be the last one. Then on that Friday, 3/22, we'll see how it goes. There's probably a good chance, at least I'll make that lap. All right. Then the following week, which is 3/25, we're going to cover 2 chapters. We're going to spend 1 day on chapter 17, which is on file, input, output, also known as IO. So we'll spend a day on that, just a day. Then we're going to jump right into chapter 18. And that's going to be, again, something that's brand new to everybody, and it's something that's called link. I don't even want to go over it right now. But we will spend Tuesday, Wednesday, Thursday, and Friday on link. That's the plan. At least Friday will be a lab too. All right. So that would be like the 29th. In fact, the 29th, we're off that day. There's no class. That's Good Friday or whatever you want to call the holiday. So there's no class then. Okay. Now, the week after that, which is going to begin with April Fool's Day, and this is no April Fool's joke, we will go over chapter 19. That's our intro to databases. All right. Now, because people say, okay, well, if we're not having any more tests, How are you going to basically grade us, etc.? And what's going to happen is there'll be on here, I'm going to ask that you do the written test. That's it. On here, you will do the written test, and I'm going to give you some kind of worksheet to work on. I don't know what it is yet. I haven't created it yet. In here, we're going to do a project together. All right, so we'll talk about databases. I'll show you how to use them, etc. All right, so there'll be some kind of a project that I will do, and I'm going to ask you to follow along and do it as well. And again, there'll be some kind of a worksheet on there. I don't know what it'll be. All right, well, oops. And then if we look at this, what that means is for 8, then we would be going over then chapter 20, which is another database chapter. For 15, we'd be going over chapter 21, which is another database chapter. And for 22, we'd be going over chapter 22, which is another database chapter. So we will go over all of those. And what that should mean is by the 26th, we'll be done with the book. All right, which means that when you come back on 4/29, that's the last week of class. All right, there's going to be working on a project and on your electronic portfolio. All right, and as far as that portfolio goes, I'll have to explain it in class, especially for those of you where this is your first class. But I just finished a meeting, and if you were wondering why, you were like, gee, well, why didn't you get on when I got on? We have meetings every Thursday between myself and the instructors from the St. Louis campus, and we were meeting. And one of the questions that was asked, and we all kind of went around, was how much do you stick to the syllabus? And I try to, but to be honest with you, if you looked right now, probably I'm way off. All right, but this, I'm going to keep this. And pretty much I'm going to try to use this as a guide so that you know exactly what's going on. All right. As of tomorrow, which is the 15th, all right, we have 1, 2, 3, 4, 5, 6, 7 weeks from tomorrow is the last day of classes. We'll meet every day except for Good Friday here, the 29th. Other than that, it'll be Monday through Friday of every week. Now, is it possible that we'll actually finish this and we won't need a whole week for some of these chapters? Of course it is. All right. But I want to give you time. We're going to do a project as a class, and then you're going to kind of have an offshoot of that project for you to work on. All right. Just so you have some kind of an idea. Like I said, I wanted you to know and have some kind of an idea as to what is going on. All right. Only other thing I'll tell you quickly, I may have mentioned it previously, but I want to say it again. I'm sitting here in the conference room at the Wentzville Rankin Technical College campus, and I'm in the Larry Elms Training Center, and we had unbelievable rain this morning. All right, there still is a tornado warning out. We had tornado sirens going for about 15 minutes straight. If by chance something were to happen, all right, I'm just going to grab this computer, unplug it, and take it with me and go into wherever we're supposed to go. And I'm hoping that doesn't happen. All right, so again, your completed Chapter 12 homework and written tests were due this past Tuesday. You can still get partial credit for turning them in late. Your completed Chapter 12 hands-on test was due yesterday. You can still get partial credit for turning it in late. And your completed chapters 14 and 16 homework and written tests will be due a week from Sunday. All right. So with that said, let's just get into this. All right. Now, I actually get some online things that I subscribe to, some of which are free, some of which I pay for. All right. One of the ones that I pay for, and it's not expensive, it's $5 a month, is I subscribe to a thing that's called medium.com. All right. And the reason I'm telling you this is they've got articles in there on virtually almost anything you can think of, but they're very hot in here on, so if I wanted, for example, an article on C# databases, all right? And what you'd see, probably, believe it or not, even though it may or may not look like it, there are probably hundreds of articles in here. All right. Some of them are fairly new. Some of them are a few years old. All right. So why am I telling you this? Because one of the things I'm going to send from you today, or send to you today, I should say, is where is it? This thing that they put out there that I thought was very good. And I don't know where I put it, but I'm going to try to find it now. That is not it. Well, let me see if I've got it here. There's a reason. I'm not trying to waste your time. I'm sure not trying to waste my time, but let's see if I've got any of them here yet. Click open. Yeah, here they are. I'm going to send you these articles, all right, a little bit later today. And they're anywhere from 5 to maybe 10 pages long each. If you don't care, then don't read them. You're not hurting my feelings at all. The first one is on encapsulation, and that's what we talked about a lot earlier. As it says, bundling stuff together. That's what our classes are. They're encapsulated pieces of information. They contain properties and they contain methods. All right, and that's what this talks about. It gives you some examples, talks about data hiding and why you'd want to do that, etc. And it's pretty well done, in my humble opinion. All right. Then, secondly, the next article, no, I'm going to get another one up, is on abstraction, which is very, very close to encapsulation. And again, they go through some examples in here, okay? But we've talked about this stuff previously, all right? What we haven't talked about yet is this one right here, inheritance. As it says, inheritance is a fundamental concept in any object-oriented programming language. It allows a class to inherit things from another class. All right. The class that gets inherited from is called either the parent class or the base class or the superclass. The class that inherits is called the derived class or the child class or the subclass. All right. And this article goes through that, I think at least. It's a start. I'm not going to say it's perfect, but they give an example, and then as it says, it breaks it down. The other thing that's in here that we're going to talk about today is the fourth part of this, which is something called polymorphism. All right. Poly means many, morphism means forms. All right. And we're going to look at an example. If not today, we'll look at it next class, which, on our Monday lecture. All right. And I'm going to send all 4 of these articles to you today. Hopefully you'll get something out of reading them. All right. So let's jump into our chapter now. So chapter 14 starts on page 453. Chapter 14, how to work with inheritance. As it says, inheritance lets you create a class based on another class. In fact, quite often what you do when you work with this stuff is you set up typically what's referred to as an inheritance hierarchy. So imagine for a second, I'm going to create one of these for you right now. In fact, I'll create a couple of them, but let's make it fairly big. All right. So I come in here and I create a class called animal. All right. And then based off of animal, I create a class. We'll have one that's called human. Let's have one that's called dog, one that's called cat, and one that's called bird. All right. There's nothing special about these names. I'm just making this up right now. No, I don't have any notes in front of me. I'm just doing this. And under human, I could have, as an example, I could have a human object named Jeff. I could have another human object named Mary. I could have another human object named Joe, etc. All right. Now I could break it down, or I could do it like that. Now with dogs, I might decide, you know what? I want to have different kinds of dogs. All right. So in other words, maybe I want to come in here and I want to put in, I don't know, a beagle. All right. And I also want to add, I don't know, another kind of dog. All right. I know that we've got a Bichon, but I could make as many of these as I wanted to. And then for cats, I could have, as an example, a calico cat, a tabby cat. And for birds, I could have, for example, a parrot. And I could have, I don't know, a robin. Okay. So I could create something like that. What you're starting to see in here is what's referred to as a class hierarchy. This would be level 0 at the top. This would be level 1, and this would be level 2. Why am I even telling you this stuff? Well, what I want to put into this animal class is everything that is in common with all the other classes. So what if I decide that, you know what? There really is nothing that these all have in common, except I guess you could say all of them are able to speak. All right. I'm speaking to you right now. A dog speaks by barking. A cat speaks by meowing or purring. A bird speaks by chirping, tweeting, whatever you want to say. So I could create a class that was called animal, and all it would have in it would be a method that was called speak. All right. Then I could have human and dog and cat and bird, and all of them could inherit from animal, which means that all of them would be able to speak. But if I had told the Jeff object to speak, I wouldn't want it to say roof, roof, or bow wow, or purr, or tweet, or whatever. No, I'd want it to be able to speak in human form. If it was a dog, I'd want it to bark. If it was a cat, I'd want it to purr or meow. And if it was a bird, I'd want it to tweet. All right. Or chirp or whatever. Why am I telling you this? Because I can take this speak method here and redefine it in any or all of these. The fact that I'm able to take this speak method and use it differently in all of these means that I am using that speak method in many forms. That's polymorphism. That's the other thing that we're going to talk about today. All right. And one more quick example of this. Imagine that I created a class that was called bank account. And I said, you know what? Every bank account must have, somebody's name. So let's just say a first name. It's whoever has the account, a last name. Okay. And they all have what? Every account should have an account number. Every account should have maybe a balance. All right. As an example. But let me move this down. When I come in here, now I can come in and say, you know what? I've got a checking account. Maybe I've got a savings account. And maybe I've got an IRA account. And I'm sure there's other ones. All right. And maybe under checking account, I've got both an interest bearing checking account and maybe a non interest bearing checking account. Maybe under a savings account, maybe I've got some kind of a special thing. So let's say, for example, I've got a gold account. And let's say that I also have a silver account. And let's just say I also have a bronze account. All right. With an IRA account, I don't know enough about IRAs, but let's just say that I've got something where I don't know. I honestly, I'm just let's just say again, let's say this could be a retirement, and maybe this one is a non-retirement. All I'm trying to show you here is what we're doing again is we're creating a class hierarchy. And what I mean by that is, do it like that. Okay, and I'll put this one down here too. I can create a bank account, okay? And I can say that every bank account that people have must have a first name, a last name, an account number, and a balance. Okay? Then based off of that bank account, I can create a checking account. So everybody with a checking account will automatically get this stuff. If I decide I want to do something differently for either the account number or the balance field, I can do that in here or not do it. I can add other things in here. For instance, maybe interest bearing here and non-interest bearing, let's just say they have nothing to do with a savings account. And gold account, silver account, bronze account have nothing to do with a checking account, etc. So what we're doing is we're creating a class hierarchy. Years ago, I took a class on this, no pun intended. All right. And it was a couple week class. It was 2 weeks long. And the guy who taught it was really interesting. He was from India, spoke very well, was an unbelievably intelligent person. He worked at a place in Wisconsin that was called Johnson Controls. And basically, they kind of have the market on most thermostats that are used. And he said that they were taking all their code that they had. It was in a different language. It wasn't in C sharp. And they were taking everything they had done, and it worked, but they were changing it to make it object oriented. And they were making a class that had a class that had a class that had a class, etc. This was a 2-year long adventure. And I said, I talked to him during a break and I just said, this is really interesting. How many levels of classes do you have? And he said, the last time I checked, there were 500 levels. So imagine this goes down 500, so you can see how complex this can be. Now, we're not going to go down to anything in that, like that at all. But I just want you to realize that it can be more complex. All right. So we're going to talk about how inheritance works, how it's used by .NET, what you get automatically in .NET without having to do anything. And then we get into how to use inheritance in your applications, how to create a base class, how to create a subclass. I've already shown you, but again, how polymorphism works. Then we're going to get into looking at this product maintenance thing that we talked about in an earlier chapter, in chapter 12. We're going to rewrite it. All right. And we're going to add a little bit to it. We'll have a couple child classes. Right now, we only have a product class. We're going to add a book class, which is a child of product, and a software class, which is a child of product. All right. Then we'll go into casting these, and that's a little bit confusing. Finally, we'll talk more about what I started to mention here, and that is abstract classes and sealed classes. All right. So we're going to hit on all of that stuff today. As it says, pretty much in a nutshell, inheritance allows you to create a class based on another class. When used correctly, it can simplify the overall design of an app. Now, with that said, you may not agree that it simplifies it. When you first learn this, you might think, well, this is going to make it harder, not easier. But the idea is, rather than having one humongous class that is just huge with hundreds or thousands or more lines of code, you break it down into classes and subclasses, etc. And it is typically, once you get all that done, typically easier to work with. So they're going to show this on the next page. Okay. So if this is a class, this right here says basically anytime you create a Windows Form application, you get this stuff. There's more stuff as well, but you get this. All right. You get text, you get a minimize box, which is that minus sign here. You get a maximize box, which is that square here. All right. You're able to close your application, show your application, and you can even do a dialogue if you want to. So if I use that, and then I go and create my own class based off of that, that says I get all that stuff. I can just use it. All right. If I decide I want to change how the show dialogue works, I can do that. If I want to change how the close or the show work, I can do that. In addition, I can add my own stuff. So I can add text boxes and buttons and objects, etc. So as it says, inheritance lets you create a new class based on an existing class. The new class inherits all the properties, all the methods, and basically everything from the parent class. The class that you inherit from, this one, for example, up here, this class would be known as the parent class or the base class or the superclass. The one that you create based off of that is called the derived class or the child class, all right, or the subclass. And it is possible for a class to be both a child of somebody and a parent of somebody. In fact, every class has got a parent except one. This class right here, even though it doesn't show it, has a parent. And that parent is way up here. And that's called the object class. That is the grand poobah or whatever you want to say. That is the top. Everything inherits from that, directly or indirectly. So a derived class can extend the base class by adding new stuff. All right. If I didn't add this new stuff here and I just created a class based off of this class, they were the same, what would be the point of doing that? So again, the reason that you typically would go in and do that is so that the derived class can extend it by adding new or different functionality. Okay. All right. So this is used in .NET all the time. You've been using this all semester, whether you realize it or not. As I mentioned, object is at the top of the hierarchy. One of the things under object is control. Those are all of your controls. Then notice that underneath controls, there's something called button base. And that's what? Buttons, checkboxes, and radio buttons. If we go down a little further, notice there's list controls. And that's where your combo box is, your list box, drop-down list, etc. Then notice there's also one for text boxes, etc. There's more than this. This is not a complete picture. But as it says, .NET uses inheritance extensively in its own classes. Yes, it does. All right. Now, object, as I mentioned, is at the top. These are what gets defined in the object class. All right. What does that mean? That means that you always have access to a method called toString. All right. If you don't use the toString method to print out an object, all it's going to typically print out is the name of the object. All right. You can check to see if two objects are equal to one another, and there's different ways of doing it, as you can see here. I'm not going to go through any of these. There's something that's called getType, which allows you to find out what type of object you're working with. All right. Again, there's another one called getHashCode, which is way over and above what we talk about in here. All right. Now, one of the things that we've learned about in chapter 12 was how to create a constructor. All right, that's one of the things that we talked about was how to create a constructor. Well, kind of the opposite of a constructor is finalize. It's like a destructor. So what it says is, okay, I'm not going to use this class or this whatever anymore, free up its resources. Okay, it goes through a method that's called garbage collecting. Do you have to worry about it? No. You might say, well, we never wrote anything in finalize, and we won't, but you can. All right. It's also possible to clone an object, make a copy of it, basically. Now, I'm not going to read these, but if you want a better explanation, probably than the one I just gave you, or a little more in depth, you can take a look at the bottom of the page there. All right, so let's talk about how to use inheritance in our own applications. So right now we have this product class. We did this back in chapter 12. Each product has a code, and I don't know if they made that a string. I think they actually made that an int, but it doesn't matter. Each product has a description. Each product has a price. Those are the three properties that a product has. In addition, any product is able to go in and display those three items, the code, the description, and the price. All right. So product is the parent or base or superclass. Now what we're going to do is based off of product, we're going to create two additional classes. All right. One of those additional classes, one of them, all right, one of those is going to be called book. So book will have a code, a description, a price, but it'll also have an author. Software will have a code, it will have a description, it will have a price, and it will also have a version. Now, we're going to have to change the get display text because if we're displaying an author, we want to display his, her, or their names. And if we're displaying software, we want to display its version. All right, so we're going to have to make changes to the get display text, and you're going to see that in just a minute. All right, then they give you another example here. All right, you've got the generic list of products that has this, and we're going to add to it. All right. So as mentioned here, you use inheritance in your apps to create base classes. All right. And then you typically also create subclasses based off of those base classes, parent, child, super subclass, base class, derived class, however you want to refer to it. So we're going to look at this now in a little bit more depth and breadth of coverage. I'm going to go till 9 o'clock, which is about 20 more minutes. And at that time, then we'll see if anybody's going to join us. All right. But otherwise, let's just go on. All right. Says now that you've been introduced to the basic concepts, you're ready to see how this is implemented. So figure 14.5 shows how to create a class that's a base class. Guess what? That's what we've been doing so far. All right. This is very similar to stuff we've been doing so far. Now, this looks a little different, this right here. In fact, let me grab this. Should be able to make a copy of this. And let me paste it in here. All right. So the first thing that you see in here, let me move this down. Okay, so the first thing that you see in here is going to be our full arg constructor. Okay. Now, when you look at it, it looks different, for lack of better words. I'm going to put this on two lines. just so you can see what's going on. All right. Okay. Then we have what? We've got here our properties. And remember, there's different ways of doing this. Okay. Finally, we've got our one method. Okay. All right. And I'm going to again move this down so that you can see. I want you to be able to see everything that we're doing here. Okay. Now, we haven't been really writing constructors that look like this. Remember, the other way we can write this, and I'm just going to put it below. In fact, I'll put it above. We'll comment out this one. Okay, I'm going to comment out this one right here. And I'm going to put this in the way we have typically been writing them. So public product, string code, string description, decimal price, okay? And then we had a curly brace. All right. And we've said something like this. Um, code, oops, sorry. Code equal code description equals description price equal price. That's the way we've typically been doing it, has been like this. This is just another way of doing the same thing. I don't want you to get confused with that. All right. So that's kind of the way we've been doing it with a full arc constructor. So these properties, code, this one here, code, this one here, description, this one here, price, are these things down here. We can put them up above as well and make them private. If we make them private, so if we come in here and make these private, so if I say private string code, private string description, private decimal price, if I were to do that, all right, and I'm not trying to confuse you here. Please realize this. But the other way that you sometimes see these written are like this. So properties, all right, and you'll see private string code, private string description, private decimal price. You see them written like that as well. If you write it like this, and I'm going to comment this out. If you write it like this, then typically after your constructor, you will see either something that looks like this, or you will see something that looks like this. And again, I'll comment these out, but you'd say public string code, we're not doing anything special in here with these. So we would say for the get, oops, come on, Jeff. We'd have a get here, and it would say return code. Should put these in comments. And we would have a set. So we have a set, and it would say something like code equal value, something like that. All right. And again, if I'm confusing you, I apologize. All right. In fact, this whole thing would also be in curly braces. like that. So there's different ways of writing these is what I'm telling you. I've tried to show you throughout the semester kind of both ways, not to confuse you, but it's just that there are so many different ways of doing it. All right, but let's just for right now, let me grab all this and let's just concentrate. Let's just concentrate for now, at least, on what they show in the book. All right. So I'm just gonna get rid of these. All right. And I'm gonna keep in the constructor that they show. And I'm gonna keep the properties that they show and their method. Okay. So again, I just showed you a couple ways that this can be written. Okay. All right. So we've got our constructor, which means that anytime we create a product, it's expected we're going to pass in a string for the code, a string for the description, and a decimal for the price. That will set the code and the description and the price. In addition, we've got a method that's called getDisplayText, which will allow us to display the code followed by some kind of a separator. Could be a blank space, could be a tab, could be a comma, could be whatever we wanted it to be. Then the price in currency format and another separator, then the description. Now, the only thing that's new really in here, other than this is another way to write this, is this word right here. That word that you see there, that word virtual, means that it is possible later that I can write my own version in a child class. I can write my own version of getDisplayText. Remember, the only thing this displays are these three fields because that's all it knows about. But if I come in and I create a book item or a book class and a software class, I'll want to show all this stuff. Plus, for the book class, I'll want to show the author. And for the software class, I'll want to show the version. I can't do that with the product getDisplayText. It doesn't know what those two things are. All right. Hopefully that made at least a little sense. Now, a very important page in this book, just so you know, is page 462. All right. I'm going to attempt to explain this in here, what's in here, and you might find it really, really confusing. And if you do, I'm sorry, but I'm going to explain it the best I can. They talk about what are called access modifiers right here. We've used two of these throughout the semester. All right. We've used private. And when you think about it in our code, virtually up until chapter 12, virtually every time we ever went in and we created our own method or we called a method like a click method or whatever, they've been private, meaning they're only known within the class that's using them. One of the things that was mentioned in chapter 12 was public. When something is public, it's open to the world. All right, now I'm going to give you an example, and it's not a good example. All right, now I realize the way things work in this world, but technically, I should be able to, if I've got a problem with the way this country is being run, I should be able to go in and either see my congressperson, all right, or even the president. I know it doesn't happen, but you get the idea. They're public figures. So they're supposed to be open and available to everybody. So even though it doesn't work that way, technically it should work that way, that if I go to the White House, knock on the door, say, hey, I'm here. I want to meet with President Biden. I've got a problem with this, whatever this is. Again, I know it wouldn't actually work like that, but technically, with him being a public figure, it should. All right. I should be able to have access to the White House, seriously, because it's a public facility. On the other hand, the reverse isn't true. I'm private, all right? So if somebody tries coming into my house and they haven't been invited in, that's against the law, all right, technically. All right, so that's public and private. Now, once we come in and we start to build something that's like this, all right, and if we create something in here up in our parent, okay, and we take this, we can make this public, we can make this private. Another word we can use is protected. If something is public, it can be used and changed here. It can even be used and changed by anybody who works with us. So even if it wasn't a bank account, any kind of an account, if it's public, technically anybody can change it. If it's private, it can only be changed inside of here. But there's another one that's called protected. And with protected, all right, if I make this protected, I can change it here, or any child can change it, but no one outside of the family, so to speak, can. So private is a new one. There's also something that's called internal. As it says here, internal is sometimes useful when you have projects that contain more than one, a solution that contains more than one project, if you want to be able to combine things together. Now, was that a great explanation? No. Is this better than the one here? Probably not. And there's even combinations. So not only is there protected and internal, but there's protected internal, there's private protected, as it says here. Do you have to really understand these? The key thing in here is that you understand that public is available to all, private is only available to the current class, and protected is available to the current class and any child classes of the current class. If you understand that, you should be fine. All right, so we've created a class. Now we want to create a subclass. So let's grab this one. Come on, someone help me here, would you please? Okay, I'm just gonna do it like, whoops. Well, let's try it like this. Okay, I'll do it like that. Copy, and let's see if it copies over everything. All right, so we just did this, okay? Now, this would typically be in another file, but I want to go through this with you to show it to you. What does this class have in it? That's what we're going to talk about right now, okay? And after we do that, we'll probably end up taking a break, okay? All right. The key component in here is this. When you put a colon after the name of a class and you follow it by the name of another class, it means one of two things. For now, it means book is a child of product, or book is a derived class based on the product base class, or book is a subclass and product is a superclass, however you want to look at it. All right. So book will automatically have access to a code, a description, and a price. All right. Now here, this is our full arg constructor. All right, but it's a little different. Notice it lists the same things that we had before. In other words, the code, the description, and the price, but it also has something new. The author. That author is this. And then what the heck is this? Well, I'm going to explain it to you kind of the way it was explained to me. And it looks like I missed somehow. We're in there. Okay. Now, oh, I did not. Forget it. And I'm not sure if this explanation is going to make sense or not. Base is a keyword. It's a keyword in the language. What this says is when you create a new book object, you'll pass it in four things: a code, a description, which are both strings, a price, which is a decimal, and an author, which is a string. This says, hey, the parent is going to take care of the code and the description and the price. The only thing you will have to take care of is the author. All right. And in just a minute, they're going to show you another one in here. And I'm going to write it now, but it's going to be software. And I think this is version. All right. And this will be, I don't remember what they made it, if they made it a string or what. Let's just keep it a string. So you can see how similar, or hopefully you can see how similar both of these things here are. Make it a little, there we go. So you can see both of them. They look almost identical, except for a few things. Well, of course, the name is different. Book is a child of product. Software is a child of product. Also, book has an author, but it doesn't have a version. Software has a version, but it doesn't have an author. Both of them in their full arc constructors expect there to be four parameters: a string for the code, a string for the description, a decimal for the price, and either a string for the author or a string for the version. And in both cases, the parent class, which is product, will handle the code and the description and the price. All right. And if you can at least sort of wrap your head around that, all right, then you've started to understand this. So as it says here, a constructor of a derived class, so the child automatically calls the default constructor of its parent. You use the base keyword to refer to a member of the base class. You use the override keyword to override a virtual member. What the heck does that mean? Well, let's grab this. I don't know if I grabbed that before or didn't grab it, but I'm going to grab it now. Okay. So in here, okay, whoa, what happened there? I don't know. I didn't, for some reason it didn't copy. So let's copy it. There we go. What you'll notice when you look in here is another new word: override. Remember how this one had the word virtual in it? That meant that I can override it and make my own copy of this. It looks the same as the other one, except we've added the author to the end. All right. And now I can come down to this one here, and I can again do this. And what's going to be different? I'm going to add the version on the end. So what you've been exposed to so far is how to use the colon for this, to show inheritance, how you use base to call the parent, and how you use override to take something that was defined as being virtual and be able to change it, add to it, whatever. All right. Okay. It is 9:01 And I don't think I have anybody here yet. All right, and it looks like I haven't. So you know what? I just think I'm going to keep going. All right, so let's do that. You're going to have to read this chapter for it to make any sense to you. I mean, for lack of better words, you've been warned. When you take your test, which will probably be a week from today, next Thursday, with your last hands-on test, which will be on chapters 14 and 16, there's only one problem on it. Okay. Tomorrow I plan on making, again, it'd be a lab period. On Monday, we're going to go through 2 or 3 examples. On Tuesday, we're going to go through 2 or 3 more examples. On Wednesday, we're going to go through a pretest, which is similar, not identical, but similar to what your actual test will be then next Thursday on the 21st. Okay. Now, the other thing I didn't mention here, it says you can use the new keyword, all right, and rather than doing it this way. And as it says there, this is known as hiding. Does that matter? No, not in the end. All right, let's just go ahead. Polymorphism. I want to show you something. I wrote this earlier today. It's not really a good example, but I want to show it to you anyway. All right, I'm going to bring this up. And I did a couple of these. I didn't get the second one totally finished, but I created something that you probably haven't seen anything that looks exactly like this before. Yes, of course I want to save that. All right. I created a thing of animals. Okay. So I created a class that was called animal. And I said, any animal can speak. Any animal can speak. Okay. Now, you'll notice that I've got the word abstract here and here. And unfortunately, it kind of means 2 different things. The abstract right here means that I cannot create a class that's called animal. It's too general. It's like, would you really tell somebody, hey, I bought a new animal? Because the first question they're going to ask is, what kind of animal did you buy? All right. Okay. So all animals can speak. This abstract means that anytime I create a child of animal, and I'm going to do that in a minute, they're all able to speak, but they'll all speak differently. What does that mean? Well, I made another class called dog. And now I'm saying that anytime I create a dog object, it's going to bark. All right. And I created another one called cat. And anytime I create a cat object, it's going to meow. And you'll notice I overrode what was in there originally. And I also created a bird class, and it's going to tweet. Okay. But then I wanted to create something underneath that. I wanted to create something more like this. So this would be animal. This would be dog and cat and bird. And then I wanted to create something down here. All right, so what do I mean? Well, notice for dog, I created a beagle, and I created a Bichon, and I created what was the other one? A husky. All right. Then for cats, I created a calico, and I'm not a cat person, and I created a tabby, and then I went up and looked online for other kinds, and there was one called a Bombay, which I thought was kind of cool. Finally, for a bird, I said, well, there can be a parrot, there can be a robin, and there can be an eagle. Now I want to run this one for you because I want to show you what polymorphism is. All right, so I'm going to set that as my startup project and run the program. All right, kind of hard to read, but let's look at it. It knows that husky and beagle and Bichon are all dogs. So when they speak, they say bark. It knows that calico and tabby and Bombay are all cats. So when they speak, they say meow. And it knows that parrot and robin and eagle are all birds. So when they speak, they say tweet. All right. It knows it's using the same speak method, but that speak method has been overridden so that dogs bark, cats meow, and birds tweet. That is polymorphism. The ability to go in and use a method, as an example, with the same name and use it in different things depending on the class that you're using for it. All right. Now they go through a big song and dance in here, and it is well written. All right. But I think it may confuse you too. And I didn't want to confuse you. That's why I showed the example that I just showed you. All right. So again, polymorphism lets you treat objects of different classes as though they were derived from the same base class. Well, when you look at it, dog and cat and bird are all animals. And what that means is beagle, Bichon, etc., they're all animals too. But we're treating dogs differently than we are cats, because when dogs speak, they speak differently than cats. We're treating cats differently than birds, because when cats speak, they speak differently than birds. And that's exactly what they're saying here. Polymorphism is most useful when you have two or more derived classes that use the same base class. All right, it can give you less stuff, so to speak, that you have to work with. All right, so next is this inherited version. So this is what we have now. Previously, in chapter 12, we had this. When you clicked add product, it brought up something that looked like this, but it only had three fields in it: a code, a description, and a price. Now, if you click add product, there's two radio buttons. If you choose book, it'll have four fields in it, the fourth being author. If you choose software, it'll have four fields in it. The fourth field is version. These two look almost identical to one another, except for that one field. So as it says, this version of the product maintenance application handles two different types of products: book products and software products. You use the radio button to differentiate which, these are two different forms, to differentiate which form comes up. So next, what you're shown here next is the code for the product class, the book class, and the software class. Very similar to what I've already shown you. So there's the product. And again, they're showing you the only difference here, and that is with our get display text, rather than just saying public string, we're now saying public virtual string, which means that this method can be overridden, and it is overridden here, and it's overridden here. You'll notice that they've also added empty constructors for each one of these. Okay. All right. So now they're also working with this product list class. Okay. That's where we list out our products. And it's pretty generically written, because whether you're printing out, go back for a page here, whether you're coming in here and you're printing out, where are you? Come on. Whether you're printing out a book or whether you're printing out software, okay, right here, we're just printing out books. No, we're not. We've got both. The middle two here are software. But notice we're printing out the same kind of stuff in that we're printing out a code, a price, and a description, whether it's a book or whether it's software. All right. And that's kind of what they're trying to show here. Now, this product list is a child of list. A list of what? A list of products. So as it says, we want to modify the behavior of the add method, all right, to provide these two methods, the fill and the save. And here's the code for the product maintenance form. All right. Again, look at what's new. For each product. And this will work to fill that box because both book and software are types of product. All right, so that will work. This stuff here hasn't been changed. Here's the code for the new product form. Well, look at what's in here. Notice there's an if statement in here now, which says if the book is, if that radio button is checked, all right, then we want to put in there version, author, otherwise version. They probably are using the same form for both of these. All right. And for the valid data, we have to validate here for the book. All right. It says author or version, but it's got to know that in this case, it's got to be basically checking the author. And in this case, it's checking the version. All right. So notice when we get into here and we're looking at the is valid data, all right, that when we got this in here, it's book.author and it's software.version. All righty. That's when we're doing the validation. Okay, now what's left, because we've got about 10 pages left in this chapter. And what's left here is probably the hardest part of the chapter. Sorry, but it is. And it says, now that you've learned the basics of inheritance and you've seen an example, here are some additional techniques that you may have to use. When we looked earlier at the object class, and remember, object is kind of the grand poobah I mentioned. It's what's in charge of everything, so to speak. It's the top level. All right. And for that, one of the things that it automatically provides is a get type method. So if we look here, notice if we use the get type, okay, we can say if the type is of type book, or you can do it this way. And since I'm using version 8, I can do it either way. This says you need to cast the product to type book, right? And that's why we've got a type of right there. If you do it this way, you don't have to. Okay. But if you want to do something specific for books, this is another way you can write information. You can write code as you can use the get type. You can also come in here and use casting. All right. As it says, another potentially confusing aspect of inheritance is knowing when you have to cast. Sometimes you don't know. You try to do something and it doesn't work. All right. So they give you some examples here. The first one, as it says, it doesn't require casting. Book B equals new book. Well, that wouldn't be anything new. You're working with a book. Now, notice here, product P equals new book. Yes, you can do that. But then you have to let it know when you're working with it that it's a book that you're working with. That's very confusing. I'd recommend not using that where you are right now.
If you come in and make a new product, notice here we create a new product which is of type book. This is a new product which is of type software. Then we try to cast it into a book. That's trying to cast an apple into an orange. You're going to get an error when you do that. All right. So as it says here, C sharp, I should say, can implicitly cast a subclass to its base class. But you must explicitly cast a base class when you're referring to one of the subclasses. So it depends on the order in which you're doing it. All right. Finally, the last thing that's discussed in here, and I've already shown you a little bit of this, but the last thing that's really discussed in here are abstract classes and sealed classes. If a class is abstract, it cannot be instantiated. You can't use it. So again, probably what I would do, in fact, if you look at what I showed you before with the example here that I showed you, all right, notice eagle, all right, eagle is not abstract. However, eagle is a type of bird, and bird is abstract. Bird is a type of animal, and animal is also abstract. So you cannot create an animal object. You cannot create a bird object. You cannot create a dog object. You cannot create a cat object. But you can create a beagle object, a Bashan object, a parrot object, etc., because they don't have the word abstract with them. Okay? Abstract can be used for classes, meaning you can't instantiate them. You can also create abstract methods, and I showed you that. When you create an abstract method, you don't put a body in there. What that means is typically it's inapparent that you will create something as abstract, and that means that the child must implement it itself. I want to say that again. All right. If I take a parent class, a base class, and I put abstract before it, that class cannot be instantiated. If I create abstract methods in there, they have no body in them in the parent or base, but in the child or derived class, you must put the body in and implement them in there. And if you don't, you're going to get an error. You want more, just take a read here on page 483. Okay. All right. Finally, the last thing that's discussed in this chapter are what are referred to as sealed classes. If a class is sealed, it's at the bottom of the hierarchy. It cannot be used and have classes that are inherited from it. So if I had come in here and I had said that gold account, let's just say that one, I said was a sealed class. That means there couldn't be different kinds of gold accounts. That's at the bottom of the hierarchy, so to speak. All right, I think we're just about done here. We are. So I will take 5 right now. And then when I come back, I want to talk very briefly. You're not responsible for this, but I want to talk very briefly about what an interface is. I'm not going to talk about generics, but I want to talk about interface. And then we'll jump right into chapter 16. All right, it is 9:20, so I'm going to start back up again at 9:25, and I'll be right back.
All right, it is 9:25, so I'm going to continue on. Now, one of the things, just so you're aware of this, one of the things that you cannot do in C# is, let's say I've got here class A. Doesn't mean anything, okay? So class A. And here we're going to have class B. All right, and what I'd like here is class C, and I'd like class C to be a child of both class A and class B. You cannot do that in C#. You can do that in a language, for example, like C++, but not in C#. In C#, child classes can have only one parent. So A could be the parent or B could be the parent. All right, I cannot come in and do this. Public class, class C inherits from class A, class B. I get an error if I tried to do that because the language doesn't support it. What if, okay, this has got everything I need in it, but so does this, and I need stuff from both of them. One way I can get around that is, instead of making them both classes, I could make one or even both of them what are called interfaces. Because although, let's even put another one in here. All right. Although in C# you can only have single inheritance, you can inherit from as many interfaces as you want. So what's the difference between an interface and a class? That's what the first pages in chapter 15 talk about. All right, so let's take a look. As it says, in some object-oriented languages, such as C#, C++, and Perl, classes can have more than one parent, known as multiple inheritance, but in C# they can't. Although C#, I'm in the second paragraph here, does not support multiple inheritance, it does allow you to work with interfaces. Now, it says here, in some ways, an interface is similar to an abstract class. In some ways, it's different. So let's look at this chart that they show here, this little comparison. Both interfaces and abstract classes can provide signatures for properties and methods. All right, both can implement some or all of the properties and methods, but it's the last two. An abstract class can only use instance variables and constants. An interface can only use static variables and constants. A class can inherit only one from only one class, but it can implement as many interfaces as necessary. Typically, interfaces start with the letter I. So interface, I mean, I just called it started with an I anyway, but I could have made it even I interface A or B, and I interface C. But if I had an interface that was called hello, I would make it I hello. You shouldn't start class names typically. You don't start class names with the letter I, because they're reserved, not reserved, that's not the right word. You can do it, but most of the time people, for what they make with the letter I, they're interfaces. All right. Now, not everybody probably even agree with that, to be honest with you. So as it says here, an interface consists of a set of signatures for one or more properties, methods, indexers, or events. By convention, interface names begin with the letter I. To implement an interface, the class must name the interface that it's going to use.
.NET has its own interfaces that you can use. I'm not going to read any of these. I will tell you that under the description there, it says, this table lists only what the author considers to be some of the more important interfaces. It is by no means a conclusive list. Let's say that again. It is by no means a conclusive list. All right? Okay. So how do you create an interface? Let's just take a look at it in here, because there's really two ways. So if I come in here to this program that I had, this animal program, and if I decide I want to create an interface, okay? If I want to come in there and create an interface, there's two ways I can do it. One way is, I'm not going to say it's the recommended way, but it's probably the way you do it most often. And that is, I would right mouse click on here. I would choose add. I would go to new item and I would find interface. Okay. And give it a name and put whatever I wanted to put in it. The other way you can do it, all right, I don't know why you do it this way, but you can create a class just like we have in here. And then you'd go in and you change the word class to the word interface. I don't know why you would want to do it that way, but you can if you'd rather. And they explain how you do it in here. All right, it's pretty much what I just said to you. Okay. The description, the declaration rather, for an interface is similar to that of a class, but it uses the interface keyword instead of the class keyword. All right. So you'll notice they're also comma separated lists. Kind of what I showed you before. I think you have to put your class. So if you're going to inherit from a class and then from interfaces, I believe you must list the class before you list the interface or interfaces. Okay. All right. And they've got examples in there of implementing interfaces. I'm not going to go through any more than that. Then the rest of it talks about some of the built-in interfaces. So I'm going to jump right into chapter 16 now. Okay. All right. Chapter 16, as it says, is broken down kind of into three areas. Four, really. All right. Organizing classes, documenting classes, using class libraries, and implementing unit testing. Now, the one we're going to talk about the least is the last one here, unit testing. That said, it's probably the most important. So why aren't we talking about it? You can buy whole books on unit testing. This book gives it 7 or 8 pages, so we'll talk about it. But what I'm more concerned with in this particular chapter are the organizing of classes and the class libraries. All right, those two things. Okay, all right. So let's jump into this. When you set up your classes, it is legal in C#. It is legal to put all your classes in a single file, even if you've got multiple ones. So notice public class, class 1, you put all that stuff in public class, class 2. Typically, the only reason you do that is if your classes were so small and they were never going to get any bigger. Still, I don't do it that way. I don't think I've ever done this. I don't think I've ever made nested classes in this language. A nested class, as you'd probably guess, a nested class is a class within a class. I want to say that again. A nested class is a class within a class. So you've got here outer class, and inside of outer class, you've got inner class. Now, I have never used this in C#. That said, This is actually something, because I know the Java programming language as well as C#. In Java, I've used nested classes quite a bit, but the rules are different in there. It's a different programming language. All right. You can take a class and split a class across multiple files. You may or may not have noticed when we go and create these classes, I should say, when we come in and we create programs. Okay, so when you come in and you create a program. So let's say that we were going to create, it doesn't matter what. All right. But when you come in and you create a program, in fact, let's do this. I didn't get to it at all, but I want to make a GUI program that I'm going to show you next week. Whoop. So let's, all right, so we've got this one here, and I don't know there it is. For some reason, my form got screwed up, and that's okay. Let's just add a form to it. So I'm going to come in and add, and I will add a form. All right, and we'll call this, it says form 2. That's fine for now. I'm going to add that. Okay, so here you go. And I'm going to get rid of this form 1 that's in here. It looks like it's garbage anyway. So I'm just going to delete it, which would screw my program up if I tried writing it now. So in here, where I've got my main, let's get rid of this whole thing. I want to show it to you the correct way. So let's delete this. I won't save anything. So I've got a console, which I've been working on but haven't finished, that you're going to see next week. You're going to get all this code, but I want to bring in a GUI. So let's come in here and let's add a new project. I'm just keeping it simple, Windows Forms app.net. And this will be employee. We'll just call it employee GUI. Okay. All right. We created this. There it is. So here's employee inheritance employee GUI. And we've got this form. Okay. You've done this countless times. What you may or may not have noticed is if I open it up and I look at the code, notice what this says. Public partial class. As an example, if we wanted to, I don't know why we would do this, but we could take this class if it was big enough, complex enough, we could combine it and put some of the information in one file and some of the information in another file, both of which would have the name basically Form 1. And that's what they're showing you in here. So it's when you've got a situation where you've got a class that's a little bit more complex, typically. It's either very large or maybe different programmers are going to work on different parts. Then you can take the class and you can make it, okay? So notice public partial class customer, public partial class customer, and you break it up over 2 files. You can do that. So as mentioned here, partial classes can be used to split the code for a class across several files. To code a partial class, you enter the partial keyword before the class keyword. All partial classes must be in the same namespace. If a class that you're working on becomes large or it's complex enough that you've got different groups of people working on it, partial classes can be helpful. Visual Studio, as it says on the bottom bullet, uses partial classes to separate the code that's generated for a form class as opposed to the code that's entered by you, the programmer. If you say, I don't get it, guess what? Yes, you do. Because not only do we have this is where we'll put our code, but remember, we also have this designer. Notice what it says here, partial class form 1. And what did the other one say? Partial class form 1. This is for our information. This is for what happens based on what we put in, that the system writes. All right. Now, the next thing they talk about in here are namespaces, which most people find confusing. I'm going to try to try and give you a simple explanation of namespaces. So when I come in here into this project, and you'll notice that when I'm working in the one I just created that I called Employee GUI, notice what the name of the namespace is, Employee GUI. I have another one here that's called Animal Inheritance Console. And what's the namespace of that one? All right, let's look, for example, under animal here. And the namespace is Animal Inheritance. It replaces dashes with underscores, but console. All right, what we'll look at next week, we'll have an Employee Inheritance Console. And what is the name of that namespace? Employee Inheritance underscore console. So the namespace basically is the name, typically at least, it's the name of your project, where certain characters get replaced with other characters, such as a hyphen with an underscore. Now, I want to go through this, not because I'm trying to waste my time or yours, but I want to make sure you've at least heard what the book has to say about this. A namespace is a container, like a folder, used to group related classes. Every C# class you create must belong to some namespace. When you create a C# app, Visual Studio creates a namespace with the same name as the name of your project. Then it stores all the classes you create for that project in that namespace. You can also nest spaces, have a namespace within a namespace. We're not going to get into that. It says for simple C# projects, like most of the ones we've been working on this semester, you don't need to worry about namespaces because Visual Studio does all the worrying for you. It says, however, namespaces may become an issue in two situations. First, when you copy a class from one project to another, and second, when you want to share a class by creating a class library. We're going to talk about that in a little bit. All right. Okay. So there is the namespace. There is a namespace within a namespace, which we're not going to worry about. You can read all these. It's pretty much what I just went over with you. All right. It says in the last figure, you learn how to use namespaces. But in the next figure, they talk about file scoped namespaces. Now, this was introduced in C# 10.0. Since I'm using 8.0, I can't even use these. All right. But you can go in and say what kind of a namespace you want it to be, block scoped or file scoped. All right. As it says, when you use file scope namespaces, it eliminates the need of braces and indentation. So some people would say it makes code a little easier to write. Other people would say it makes code harder to understand. Just depends in many ways on your point of view. All right, so that's part one. Part two in here is on how to document your classes. And they talk about how to add XML documentation to a class. Let's see if I can find this.
I don't want that. It's too much. Let's see. That might be it. Nope, that's not it. I used to have, no, not a really, really good introduction to XML. I had it, but it was in a different article, and I'll see if I can find it. Let's just talk for a few minutes about XML. All right. You may have heard some of this already. If you have, sorry, I'm not trying to bore you, but I'm trying to be complete in here. Okay. So XML is about, I would say, it's about 20 or 25 years old, something like that, maybe 30 years old. XML is an acronym that stands for extensible, the X is EX, extensible markup language. Back in the mid 90s, 1990s, somebody came up with the bright idea that basically we shouldn't be using HTML anymore. It had served its purpose and it didn't need to be used anymore. So they came up and said, we're going to start a new language and it's going to be called XML. It wasn't met with a lot of acceptance. In fact, when you went from HTML to XML, they even put a kind of an intermediate language in there that they called XHTML. So what's the difference? If you've ever looked, so if I come out here and I type in, for example, W3 schools, HTML tag list. All right. So if I come in here, I want a list of all the tags. Well, I guess you could probably use this, geeks for Greeks, geeks for geeks. So these are all the tags. All right. I don't know how many there are. Let's say there's about, 125. Okay. So those are HTML tags. So HTML is a tag-based language where there is a finite number of tags and they're all used in a certain way. Okay. XML, you can create your own tags. Now, this led to some problems because there's a lot of different dialects or derelicts, whatever you want to call them, of XML. For example, there is Chem, CHEM XML that's used for chemistry. There's Math XML that's used for mathematics. All right. There's all sorts of them. Okay. I've never looked it up, but I know at one time there were at least a couple hundred different types of XML. Part of the problem is when people got to make their own tags, what if they conflicted with an HTML tag? So if you were talking about a table, do you mean a table with 4 legs? A wooden thing with 4 legs in it? Or are you talking about an HTML table? So there were all sorts of problems. XML is still used. I don't mean to at all talk down to it. It never, in my opinion, it never reached the level of acceptance that people thought it would. All right. But much of it has been displaced today because in the past, where people used XML for a lot of things, today they use JSON, JavaScript object notation instead. Okay. But XML can be used for documentation. Now, you know this, that if I come in here and I type in /*, let's just hit it a couple times, I can say, for example, this is a multi-line comment. You've seen that kind of stuff before, nothing new. And I can also come in here and do this and say that this is a single line comment. But if I come in and make 3 forward slashes,
You may or may not be able to tell, but that is not green, that is gray. This is an XML comment. Now, this is green, but this is gray. So XML comments are designed for you to be able to put in, extra internal documentation right into your program. Now, when you look here, what kind of documentation? Some of the things that you can show are put here. So for instance, you've got validator. You could put a summary up here that explained, this is provide static methods for validating data. Yeah, that's true. That's what it does. All right, but you could have added more if you wanted to, but notice those are in XML documentation. It is possible for you to print out XML documentation separately if you're so inclined. All right. Not only is there a summary, but if we start to look in here, here's another one with a param. Those explain what parameters are being passed in to a routine. You can put the type, you can put possible values, you can put whatever you'd like in there. Then if you keep looking, there's a return, which talks about the return type, if there is one. I guess it's returns. There is also a value, as it says, describes the value of a property. So XML documentation provides additional internal program documentation. An XML documentation line starts with three slashes, and these are the things that you can use in them, with them. How to view it? Says once you add it, Visual Studio will use that documentation when it displays screen tips that appear in the Visual Studio editor. And they show a couple examples of that here. So there it is. All right. To me, the heart of this chapter, as far as what I think I want to get through and across to you, starts right here. And it's creating class libraries. All right. One thing, hopefully you notice this, but if I go back, and I don't know even where I've got this stuff, but I'm going to look real quick. Let's see. Okay, this will work. This is that stuff we did at first when we started working with this, with object orientation. You may remember this. We went through the BMI program a couple times, and we went through an employee program. All right. And if you look here, if I look at BMI OOP1, okay, there's a person class. There it all is. Then if I go to BMI 2, there's a person class, and it's basically, it is the same thing. And there's a validator class. Then if I go to EE12.1, I think that was garbage, but let's go to employee 1. There's an employee class. All right, it's about 130 lines long. Then if we go to employee OOP2, there's an employee class. And again, it's 130 lines long. All right, why did I show you that? When you've got a class library, just like a library that has books, a class library can be used. A class library, let me say that again. A class library, okay, a class library can be used as a repository for classes. So I didn't set this one up like this, but I did, or I could have created a class library and taken every, basically I could have put in there, for example, person, validator, and employee. That would mean that any of these programs would be able to come in and use those classes. Now, why is that important? Well, I mean, if you look at the example here with the employee, all right, if I make a change into the employee class here, but forget to make it here, I could be in a bit of in some trouble. Okay. But if I use a class library, it being a central repository, it means that all of those, see this again, it means that all of the classes that I put in there are available to all programs. Not only that, I mean, validator is a great example. A lot of times what you do is you put your utility types of classes into a class library, and then you can bring them into any program you want. Now, is there a little bit more to it than it? Of course there is. If I want to create a class library, what I have to do is literally, I have to come in then and create a new project. So if I come into my solution and I do add and I do new project, notice, hopefully, what you'll notice is one of the things that I can put in here is I can type in class library. And if I use this, or I can use one of the other ones, but if I use that one, notice what it says. A project for creating a class library that targets .NET or .NET Standard. So I can use that and put into that as many classes as I want. All right. Now, there's a little more to it than that. So let's just do this. All right. Hopefully I'm not going to screw this up, but we'll see. So I'm going to right mouse click on here and I'm going to choose, in fact, let's do this before we even do that. All right. Just so I've got the original, let's work with a copy. All right. And either this is going to work or it's going to be a flop and failure, but either way, that's okay. I'll be able to show you pretty much what's going on in here. So I'm going to come in here and I'm going to open this up. There we go. And I want to add a class library. I'm going to pretend, for lack of better words, I want to say this again. All right. I want to pretend that, okay, all these programs, I wanted them all to be able to use these, the validator class and the person class, okay, and the employee class. I want all these programs to be able to use this. All right, am I going to have to make changes? Probably, but let's just take a look at what we want to do here. So I'm going to right mouse click on the name of my solution, and I'm going to choose Add New Project. Again, I'm going to go to Class Library. All right, notice I've even got it over here, Class Library.NET Framework. Now, usually you don't have to do this, but you usually put the word library in here. So this is going to hold a bunch of utilities, helper programs. So I'm going to call this utility library. All right. And it's going to put it inside of the same name, same place I am, same location. So I click create. And it created this new utility library. Now I wish I didn't do this, but I wish I would have made that U capitalized, and I didn't. So I'm going to see if I can rename it and capitalize the U. Okay, I think that'll be okay. And I'm going to come in here and do the same thing here. If it gives me an error, of course, I'll have to go back and revert back. Now, the thing is, on this, it gives you a class which is basically kind of ridiculous. You don't need it. We don't need it. Okay, I don't need this. So I'm going to get rid of it. So I'm going to come over here to class1.cs and I'm going to delete it. All right. Now I could come in here. And create whatever I wanted to, but I've already got copies in here of the person class. I've got copies in here of the employee class, and I've got copies in here already of the validator class. So I'm going to come into my utility library here. I'm going to right mouse click and I'm going to add, but rather than new item, I'm going to choose existing item. All right. And I want to find that. So let's see. I know that in my BMI OOP2, I have in there my person class, and it looks like I also have my validator class. So I'm going to add those, and notice it brought them in. All right. And I'm also going to come in here and do one more add, and it'll be an existing item, and it'll be from employee2, and I'm going to add employee.cs. So I now have in here these three classes. All right, I've got an employee class. And you'll notice everything is public. That's good. I'm looking for something that might be private in here. The only private things I saw were these class variables, and those should be private. That's good. Now let's look at the person class. Again, there's some constants, fine. And I don't know if it'll make me do that, but I'm going to even make these public. Okay. I've got these, they're public. We did it the other way here. Everything in here, again, as far as I can tell, is public. Well, that's good. So file, save all. Now, validator will be different. Why? Because validator, oh, I guess these are okay. These have to be public, but they have to be static. I'm never going to create an instance of the validator class. I want to say that again. I'm never going to create an instance of the validator class. Now that I look at that too, I should really rename that. See if we can do that, and hopefully I won't screw it up. All right, so that looks really line in is the way it should look. All right, so that big deal. What the hell did I just do? Not really very much the way it appears, but I've done a lot. All right, now I want to be able to use this. In order to be able to use this, what I want to do is two things. First, I have to basically do what's kind of referred to as register these. So I'm going to go back up to where it says utility library right there. I can close these. I want to save. I can close that. I can close that. And I can close that. I'm going to go way up to the top where it says utility library. I'm going to right mouse click on it and I'm going to choose build. And when I click build, I want you to look. I know it's hard to see, but I want you to look down here, way in the bottom left-hand corner of my screen. When I click build, it says build started, build succeeded. So I built those classes right now. Those have been built. Does that matter? It does, and I'm going to show you why right now. Now, I'm going to make a bunch of changes to my program. Could I screw it up? You know me. I definitely could. All right. So I'm going to go to BMI OOP here, and I'm going to remove the person class. I'm working with a copy here, so if I really screw it up royally, it's okay. But that's going to give me a bunch of errors in my program. I'm going to go to the BMI2, and I'm going to remove both the person class and the validator class. Okay. Now I'm going to go to employee OOP1, and I'm going to remove the employee class. Finally, I'm going to go to employee OOP2, and I'm going to remove both the employee class and the validator class. All right. So now what I need to do is I need to establish a way to communicate between this utility library where I've just added in there Wow. I've got person. What happened to the rest of them? Oh my goodness. Well, this ain't good. All right, let's see if I can go grab them from the original copy. So I'm going to come back in here. I don't know what happened here, but it's okay. All right, so I'm going to right mouse click and again choose add. And again, I'm going to choose existing item, but now I'm going to grab it out from the desktop. 224, and right now the only one that's in here that I can see is person class. Okay, so this has got to be those what was this called? This was called EE12 and practice OOP. All right, I want them from here. So EE12 and practice OOP is right there. Okay, I'm going to try to grab them from there right now. I don't know what happened. So I'm going to right mouse click. In fact, no, it should be all right. Right mouse click and choose add existing item. I'm going to go to the desktop, my 224 folder, my EE12 and practice OOP, and I want to grab from there. I want to grab employee and I want to grab validator and add those. There they are. I don't know what happened, how they were removed, but I now have in here employee, person, and validator. There's employee, there's person, and there's validator. Like I said, what happened? Don't have a flaming clue. All right. Now, I'm going to go back and rebuild these, but before I do, because I built that before, I shouldn't have, because what do I want to do? Well, this is called what? It's called utility library. So the namespace for this really should be utility library. Just like that. All right. And I'm going to take that one. And that's my validator. I'm going to do that to my person. And I'm going to do that to my employee, because remember, I'm telling it where it lives right now, for lack of better words. I'm letting it know where it lives. So I'm going to go back now and do a file save all. All right. And I'm going to go back to this utility library and I'll do a rebuild because I built already. All right. And I can just do a build too. It doesn't matter. And it says build succeeded. Now, I still haven't established communication between these two. So I'm going to see if I can do that right now. Let's go back up here to our employee one here. That's right here. And here's our BMI. Okay, there it is. Now, is it giving me errors? Right now, it's giving me two errors. It says the type or namespace person could not be found. Are you missing a using directive? Yes. Are you missing an assembly reference? Yes. So I'm going to show you how to add those. All right. Now, for some reason, when you do this, it doesn't always take. I don't know why, but what I am showing you is a way of doing it. And that is, I'm going to come to my project, which is BMI OOP1 right here. I don't need that open. All right, I'm going to right mouse click on the name of the project and I'm going to choose add. But this time I'm going to go down and find project reference. All right, and it's showing me, what do you want to refer to? BMI OOP2, all these. Well, guess which one? I want the utility library. Right there. I want that utility library. All right, I want to be able to use that. So I'm going to click OK. Now, that usually works without a hitch, but where occasionally you'll have problems with this is what I'm about to do next, right? And that is, I have to put in a using statement that says using utility library, right there. Oops. Now I'm communicating between this project and this library. All right. And now look and notice I don't have any errors anymore, but there is no, repeat, there is no person class in here. But when I come in here and I type in person, it should be grabbing it from here. Let's see if the program still works. So file, I like to do a save all, and I'm going to make sure that this is my startup project, and I'm going to run it. Let's close everything else that's open here. It was that orange or peachy color, I think. There it is. So if we do come in, Jeff Scott, and I'll put in my ideals, which are 72, which is what I am, and 175, and unfortunately, I'm much more than that. And I click. Everything worked. But it is now grabbing the person class from my class library. Great. So that one works. Let's see if we can do the other ones. All right. So again, a file, save all, and I'm going to close this one. Now I'm going to go to OOP2 here, and I'm going to make that my startup project. All right. And you'll notice on here, now it's giving me a boatload of errors, because not only does it have those same things that it can't find person, but it can't find any of this validator stuff. All right. So I'm again going to go in and right mouse click on the name of the project. All right. In fact, I don't even need to do that. All I need to do is to come out and go to my code here. And again, notice how I've got using BMI OOP1. Doesn't even know what the hell that is. And that's not what I want. I want using utility library. Now, it's giving me an error. It doesn't find it. The other one it found right away. This one it didn't. This is the problem that you get with this. So I want to see here. It says it could not be found. Are you missing a namespace or a directive? I don't want to remove it. I want it so it recognizes it. All right. And I don't know why this happens. I don't know why the first one, it went like that. And this one, no, I don't know. All right. But if I come here, I can try this, and I can come in here and I can go down again and add and try doing it like this, a product reference like we did before, project reference. And I come down again to utility library and I say, okay. Now notice that went away. Boom, all of our errors went away. Why did I have to do that on the second one and not have to do it on the first one? If any of you figure that out, you're smarter than I am, so please let me know. All right, but now I want to see if I can run this second one. Notice the using statement. So file, save all. That's giving me an error. It says program does not contain a static main method suitable as an entry point. We'll fix that in a second. What that usually means is if I go in here, somehow I don't have a program.cs file like I have up here. I don't know why. So let's copy this one. Now I'll have to make changes. All right. So now I'm right here. This has got to be BMI OOP2. All right. And hopefully that's the only change I have to make. It says it doesn't have a main. It should now. So file, save all. Is it still going to give me an error? It could. All right. All right. I'm going to do a file, save all. I'm going to get out of here and I'm going to bring it back up again. Why? Because there's weird stuff that you have to do in this language sometimes to get things to work. Now we'll see if I still have that error. So I'm bringing up the second one. There it is. It's yellow now. Previously, it was that orange or peachy color. And I'm going to say that I want that to be my startup project. Let's run it. I could get an error in here any place. All right, calculate. Yeah, I still get my error messages. So let's put in Jeff Scott 72, 175, and boom, it works. If I put what I really am, which is about 255, unfortunately, it says I'm obese. All right. If it puts down where I'd like to at least get by the end of the year, I'm overweight. But it's working. And the point is, this program is now, when you look at my program, all right, it still has, wow, it still has a validator class in it. Okay. There's a validator here. Where's my library? Wow, what the heck happened to my library? Look at this. Employee is back here. Wow, wow, wow. Let me save this. And let me bring this one up. I want to make sure I'm using the right one. There's utility library. So it should be in here. There it is. Okay. Maybe I was running the wrong program. I don't know. But so this is employee OOP1. That's fine. This is employee OOP2. All right. So let's make OOP2 our startup and let's run it. Okay. That's the employee one. I'm sorry. Let's go back to BMI OOP2. That was my error. So let's fix that. So when we went first, you'll notice that in BMI OOP1, all right, there are no classes in there anymore. Okay, but when we run this, was that peach colored one, and I put in John Doe, and John is 66 inches tall and 111 pounds. Whoops, not 11 pounds. All right, and he's underweight. It's all working. Okay, so the bottom line is I still have complete program functionality, and it is now grabbing the class that I need in here, not the validator. I'm not using it here, but the person, it's grabbing it from here. Now let's look at this second one. So again, I'm going to make that the startup project. I'm going to bring that up. I think it was yellow. It is. And again, when you look in here under BMI 2, again, you'll notice there is no person class. There is no validator class. I'm not getting any errors. So I think I already said it, but let's set it as our startup and run it. Don't want that. Why is it giving me that one? Oh, because it's BMI OOP2. Set a startup project. There we go. It should give me this yellow one now. So again, Jane Doe. Jane is 62 inches tall and weighs 109 pounds. She's of optimal weight. The point is, it's working. It is now using, the program is now using, this program is now using, all right, my class library. So let's go to the third one. So I've already shown you OOP1 and OOP2, BMI OOP1, BMI OOP2. Here's employee, and again, you'll notice in here, if you look, there is no person or validator in there. All right. Now, I don't know if it's got the linkage, so I'm going to right mouse click on the name of my project and choose add and choose project reference. And again, go down to utility library and click OK. Then come back up here, view my code, and I want to using utility library. Okay. Again, my errors that were in here are all gone. Let's make this our startup project. Let's save it and let's run it. There it is. There she is. Everything's working. Okay. I don't think I did any validation on here. There is some, but not much. Let's bring up the last one then. So I'm going to close all these. And I'm going to go to the last one, which is our OOP2, employee OOP2, and it's blue. I'm going to right mouse click on the name of the, again, on the name of the project, add, go to my project references, go down to the utility library, click OK, right mouse click, view my code, and put in my using statement. Okay, now, right now, it's giving me this in this color, which isn't good, which says to me it's not recognizing it, but we'll see. I'm not getting any errors here, so that's good. Let's set employee OOP2 as our startup project, and let's run it. See if we get errors. Not. So just like before, Jane's husband, John Smith. John is 70 inches tall, he's 5'10", and he weighs 190 pounds. Oh, that's the wrong one. So employee number 23456. He works 45 hours a week and he makes $30 an hour. There you go. So what I have shown you is how you can go in and create a class library, how you can take existing classes that are part of projects, move them into that class library, and utilize them in multiple programs. All right, so let's kind of wrap this up, and let's talk about what we're going to be doing next week. All right, so this again is for next week. Okay, the first thing I'm going to do next week is I'm going to go in and I'm going to do two of these problems that are here, whoops, for I'm going to choose this use inheritance. All right, and I'm going to use exactly what they have here. I've made mine a little bigger because it's easier for you to all read. And again, just like they showed in the book where they had book and software, we're going to have plant and supply. If you choose plant, you'll get item number, description, price, and manufacture. If you use supply, you'll get item number, description, price, and I don't remember what the last one is. All right. So we'll do that first. All right. Next, we're skipping all the stuff for 15. I'm not going through the XML documentation. Try that one yourselves if you'd like, but we're going to attempt to create and use a class library. All right. Then when we get done with those two examples, this will be Monday. All right. Right now I've come in and I have created, it's pretty simple. I've created 3 iterations of a calculator program. All right, it's in here someplace. It's not that one. Rid of that. It's not that one. It's right here. All right. Some of these are garbage, but that's okay. All right, because I'm going to redo these for you in class. First thing I did was I went in and created a simple calculator, very similar to what we had done earlier in the semester. All right, so let me set that as a startup project and run that. You'll notice if you look right here, it is a console app. So please enter a number, 57. Please input another number, 14. Then you can add them, subtract them, multiply, divide, etc. So if I do a divide, all right, run program again. If I say yes, it asks me for 2 more numbers. Nothing important there, nothing big. All right, but if you look at that one, it has no classes in it. There's nothing, no classes being used. All right, then I went back and rewrote it. There's still, you say there's no classes being used, but you'd be wrong. Because I went going into the class library here, and I made both a calculator class, add, subtract, multiply, divide, modulo, and I brought in the validator class. All right. And what I hope to do, because I realized I didn't do any inheritance in here, I might go back to the calculator class and inherit off of that, maybe some scientific functions or something, if I have time. All right. And the third one, the third example is a GUI of this. Very similar to what we've done previously in class. And you'll notice that if I run this one, right, so if I run this and I don't put anything in there, get all those errors, right? And if I come in here and put in 47, and here's our plus, minus, multiply, divide, we'll do another divide, and we'll put in 19 here. We get our answer, okay? Nothing big about that, all right? It will handle it if I put in garbage, all right? I didn't do anything with negative numbers. In fact, I don't even think I checked for divide by 0. So let's see if I do a divide by 0. I don't remember if I did anything for that or if the program will blow up. Oh, it just says 0. I guess I did. The point is this. If you look at the code for this, and you're going to get all this code. If I ever forget to put that out there, please remind me. But if you look here, wrote this yesterday. We're creating a new calculator object right there from right here. So we're using the class library, which meant that at the top of the program, we need using calculator library. So we're going to go through on Monday, we're going to go through several examples that will build upon each other. We'll start with, again, going over 14.1 and 16.2 from your extra exercises. Then we're going to look at this one. When we get done, if we have any time left, and we probably won't. So then on Tuesday, my plan is to go through at least one of these 3. These are the 3 problems that you have for your homework. I might go through 2 of them. I don't know. But the first one is letters. Create a GUI app for a letter delivery service. Now, I know it's a little behind because I know that stamps are now more like 70 cents each or something, but it's fine. So we're going to have a letter class, and that letter class will have a child class called certified letter. So a certified letter is a type of letter. All right, we'll look at this one. Then we will go to this one, which has got a really complex interface, but it's not really that bad. When you look, we've got 2 labels, 2 text boxes, 3 radio buttons inside of here, inside of a group box, 5 radio buttons in a group box, 5 radio buttons in a group box, and 5 radio buttons in a group box. All right, but when you look, it's a little bit more complex because we have here, is it unframed? Is it matted? Or is it framed? All right, so if it's unmatted, it's basically this. If it's matted, it's basically this. And if it's framed, it's basically this. This is going to provide us the chance to talk about this one and even deal with enumerations in here. If you go, I don't know what an enumeration is, you will by the time we get done. One of these, I'm sure I'm going to make you do yourselves, is going to be this. This is an extension of the chapter 12 homework problem. You've already got much of this done. But we'll have to add to that. Withdrawals will now have a 1% fee on it. Okay, and we're going to add 3 types of accounts. Right now, you basically have a bronze account. We might change that to a minimum balance of 25. I would like to do that. In fact, I wish I would have, but didn't. All right, so we'll just plan on doing that. We'll make that 25. All right, and they can only view their current balance, deposit, and withdrawal, all the stuff we had. Then we'll make a silver account, which is a type of bronze account, but it adds to it. You can print out the last 10 transactions in a new window. So that could either be a form or that could be a message box. Then we'll have a gold account, which will print out the same information, but it'll put it in a fancy statement that you can design. Notice that for a silver, it needs a minimum of 1,000, and for a gold, it needs a minimum of 5,000. Don't say, well, geez, 4,000 more just for a fancy statement. The idea here is what we're trying to get across to you is how to perform the inheritance. All right. Then, and I've got it in here someplace, so I'll have to look for it. Give me a second. We're almost finished. Let's see. We will have a pretest. If I can find it. Let's look in here and see what we have for pretest. Of course, whenever I want to find something, there it is, 14 to 16 pretest. This is going to be similar, not identical, but similar to what your test will be next week. All right, notice we have 2 different types of employees. We have an hourly employee and a pieceworker employee. Now, neither one of them are chosen. If I choose hourly employee, it's going to bring in hours worked and an hourly rate. If I choose pieceworker employee, it's going to bring in, wherever, someplace in there, I've got it. Come on. The number of pieces they made and the price they get per piece. All right. And if you say, I don't get that, you will. We will spend all period Wednesday going over this pretest from scratch. All right. I will make sure I send you the pretest no later than Monday. So you should now understand, going back to what we talked about before, and that is this. So next week, the week of the 18th, I will on 318. So these will be examples. We'll call these examples 01 and examples 02. Then on Wednesday of next week, we will have the chapters 14 and 16 pretest. All of this will be saved. Anything I do here that's homework won't be saved, and the pretest will be saved. All right, so I had 18, 19, 20, 21. So that means that a week from today, this will be the hands-on test. And then Friday will be a lab. The following week, again, we'll spend a single day on file input output. I'll lecture on it, go through a fairly simple example. The rest of the week is going to be on link. Tuesday, Wednesday, and Thursday. We have no class on Friday. So on Tuesday, it'll be the link lecture. All right, on Wednesday will be a link practice 1. And Thursday will be a link practice 2. All right. We will go over those together. We will be building programs, etc. together. Everything that I do there, I'm planning on probably every program I'll save. Okay. Then the following week of the 1st, we'll have our introduction to databases. Okay. So what we'll start doing on 4.2, 4.3, 4.4, and of course 4.5 will be our typical lab day. But on here, we will build our database example 01, then a database example 02, and finally, this is the one you're going to have to do with me, a database example 03. If we can keep up with that, that'll mean that in this week, we'll get in here. We may be able to collapse these and do these faster. I don't know. You will have on here an assignment for chapters 14 and 16. You will have to do the homework and the written test, and we'll have our last hands-on test. For chapter 17, it'll be written test only. For chapter 18, it'll be written test plus one of these practice things that we're going to do together. Then when we go to chapter 19, it will be the written test and one of these examples we do together. Same with 20, same with 21, same with 22. All right, one day, possibly next week, I'm going to go back and review how to do the electronic portfolio and how to do the and how to save it out to the internet. All right. So if you've already done a portfolio, if you're not one of the new students this semester, you won't have to tune in for that. But I'll let you know when that is. So we're doing well right now. Tomorrow will be lab. So for our week of 3/11. Okay, this is what we did this week. Monday, remember, was a lab. Tuesday was a lab. Yesterday was the chapter 12 hands on test. Today was, oh, hello. Was the chapters 14 and 16 lecture. Tomorrow, then, will be a lab. I'm going to try to take this and anything that I talked about today and make sure that I've got all that stuff available to you when I send out the email later today. Now, it's 10:40. Normally we would have had 2 breaks by now. I only took a 5-minute break. All right, but even 2 10-minute breaks would put us at 11 o'clock. All right. So that would be 3 hours, which is about what I usually go. So I'm done in here. Again, you will be sent this stuff. I'm going to try to send you that. And I'm going to go back into here. And try to find that XML document and anything else. And also those Medium documents. And I'm going to send all those out. All right. There was nobody here today. I think it worked out okay. I'm sorry if when you got on this morning, I didn't get back on. Like I said, it was 2 things. I had a meeting with the other IT instructors, IT AWD instructors from St. Louis. That was from 7:45 until 8. And then right at 8 o'clock, I got a phone call from my doctor. All right, I don't want to go into it. It's nothing serious, but they had to ask me some questions. All right, and I didn't want to share that with everybody, so I did not get in until later. Apologize for that. Okay, and I will talk to you on Monday. No lecture tomorrow, 10 or 3:15. No lecture tomorrow. And finally, again, Monday of next week, we're going to go through examples for 14 and 16. Tuesday, examples for 14 and 16. Wednesday will be the pretest. Thursday will be your hands-on test. And Friday will be lab. That's really, as far as I can tell, that's all I can think of. All right. Okay. Sun is actually coming out here. I hope it is by you as well. And yeah, it's about right. I hope that you have a nice weekend. I will talk to you on Monday, the 18th. Have a good weekend, everybody. Thanks.